everyone, in this video we are going to determine the formula for surface area represented as letter S of a rectangular prisms. So what is an example of a rectangular prism? A box is an example of a rectangular prism. So we have here a picture. The properties of the rectangular prism is that first, the top and the bottom, by the way, all of these shapes are rectangle. So all of the faces are rectangle, and the top and then the bottom will have the same shape and they are congruent. And then the left and the right will have the same shape and they will be congruent. And then the front face and the back face will have the same shape and they will be congruent. So these are the parts of the prism. First, we have the length, and then we have the width over here, and we have the height. So I'm going to use a different color of marker to label what are the heights and what are the widths and what are the lengths of this rectangular prism. So let's start with the height first. I'm going to use green. So everything that is in colored green are the height of this rectangular prisms. So the broken line that we have indicates that it's located at the back. Now we will use red for the width. So there's gonna be 4 widths here. So that's the first one, that's the second one, this is the third width, and this is the fourth one, which is located at the back. So it's a broken line. And I'm gonna use blue for the length. So these are the lengths of this rectangular prisms here. So prism, this is going to be a broken line because it's located at the back of this solid. Okay, now in order that we can find the surface area, by the way, if we say surface area, the total surface area, it means that it is the area of all the faces added together. So if we can determine the area of the left, the right, the top, the bottom, the front, and the back, that if we add all of them, then that is the surface area or the total surface area. So in this problem that we have here, we are going to draw the parts. We are going to draw each of these face separately so we better understand it. So we start with the top and the bottom. So for the top and the bottom, the length is in blue. So I'm gonna put that in here. So I'm taking away. So if I could take this off of the picture, I'll put it in here and I'll paste it over here. So this is the top. So this is the shape of the top. So that means this is the length because it's in blue, and this is made up of a red line right there indicating that that's the width. And then there are 2 of them because it's both top and bottom. So I'm gonna draw the other part here. So again, this represents the top and the bottom. So I'm gonna label this. This will be our top. So we're gonna represent this as the top, and this one right here is the bottom. Now let's see what are the measures for this shape here. So for the top, we have the length and the width. This is the blue represents the length. So this is the length here. And then the width is the red. So I'm going to write W here. The same thing for this. This is the length and this is the width. So that is for the top and the bottom. Now let's look at the left and the right. So I'm gonna draw that over here. So if only I could take this shape off of the picture and paste it over here. So this would be green. So I'm gonna use green for the height. So that's the height right there in green. And then the width is red. So I'm gonna use red and red. So this is representing the right. So I'm gonna write right for this, and then let's draw the same picture, and this corresponds to the left. They have the same shape because they are congruent. So this will be representing the left. Okay, so the label for this would be, this is the width, so that corresponds to the width. So again, I took this shape off of the picture and put it here. So that means this is the width. And then this one right here in green is the height. And so for the left side, the same thing, the width and width. So this is the width. and this is the height. So I'm gonna label that as height. Now I am going to draw the front and the back. So we complete everything. Actually, there are 6 of them. So top and bottom, 2 of them. Left and right would be another 2. Then we are left with the front and the back. So let's draw the front and back. So it's gonna be green for the width. So I'm gonna put the back, the front and back here. So that's gonna be green. So let's have green for the front, and then blue for the width. So this is the width right here, and then so I'm gonna draw another picture. This represents the back, and then the height is the height is green. So the label for this would be length. That this is, by the way, for the front. So this is for the front face, and this is for the back face. So then that's the length, and that's the width that's the height. So that represents this. So that's the green is height, and so this is the length, and this is the height. Okay, from here we are now ready to determine the area for each one of these. So to find the area for each of these, we are going to multiply. Area means 2-dimensional. So for this problem right here, the area for this that would be length times width. The area for this bottom would be length times width. The area for this right would be width times height. Again, area is 2-dimensional. That means we're multiplying 2 dimensions. And then the area for this is width times height. Okay, we're ready to find the area for the front and back. Let me write, this is actually the length, and this is the length right here. So that's length and height, and length and height. So that corresponds to the length and height. So to find the area for this one, for the front and back, I'm going to write the area on top here. So the area for this would be length times height. And then this one would be the same thing. Area is length times height. So we got all of them covered. Now to find the surface area. So surface area is the total area of all of these 6 shapes. So I'm gonna write S. So S is actually equal to, first we add all of them. So we're adding all of the areas. So that would be length times width. That's the first one. Plus another length times width. That's the second one. Plus that would be width and height. So that would be width times height, and another width times height, plus another width times height. And then we have the front here. That would be plus length times height. And then another length times height for the back. So that would be length times height. Now we combine like terms. Like terms means those are the same. So if you observe, if you can see, there are 2 length times width, because the top and the bottom correspond. So they are the same. So they're actually congruent. So that would be 2 times the length and width. So there are 2 of them. Plus there are 2 width and height as well, which corresponds to the left and the right. So that would be 2 times width times height, plus there are 2 length times width, and that corresponds to the area of the front and back. So that would be 2 times length times height. So then from here we can get the common factor some more. So that would be 2 is the common factor to all of these. So then the final equation, or the simplified equation of this, would be length times width plus width times height plus length times height. So we put the 2 out. So because it's a common factor, this is the formula for the surface area of a rectangular prisms. So this will be the equation that we're gonna use. So I'm sure I just showed you the process on how to find this. So let's have an example to better see how we use this equation, how we use this process to find for the surface area of a rectangular prism. So it says here that this is a rectangular prism right here, and we are asked to show the work for the surface area using two methods. So if in any case you have trouble memorizing the formula for surface area, the go-to method is we are going to take all of these parts separately, find the area for each of the parts, and that would be the surface area of the prisms. So we're gonna do two methods. That means we're gonna take all of these pieces, like 6 pieces, like separately, and find the area by adding them all up, and we're going to use the equations that we got. They should be getting the same answers. We're gonna start first with using the by taking all of these parts separately. So this one right here is also at 2 feet here because this parts correspond. This would also be 5 feet here because these two corresponds. And then in here, this would be another 2 feet. And then the height here would also be 5 feet. Okay, because they correspond, they're congruent. So in this part right here, this would also be 4 feet. Okay, so let's draw each of the parts. So we're gonna start with the top and the bottom first. So this, if I can take this off of the picture, I'll put it here. So this will represent the top. So I'm gonna label this as the top here, and then the measures for this would be 4 feet, and then this side right here is 2 feet. So that's the top. Now I'm going to take the bottom and draw it over here. So this would be exactly the same shape because they are congruent. So I'm going to draw the bottom here, and then I'm going to label this as the bottom. So then the measures for this would exactly be the same for the bottom. We have 4 and 2. So that would be 4 feet and 2 feet here. And then I am going to draw the left and right. So I'm done with the top and bottom. We are going to do the left and right. So we're going to start with the left first. So for the left side, so I'm going to draw another rectangle here. This will represent the left. So the measure for this, so I'm going to label this as left. And then this other one right here is also left, of the same shape as the left and right would be the same. So this would be the right here. And then the measures for this would be 2 and 5. So I'm going to write 2 feet here. And then this is 5 feet. And then the same thing for this. For the left and right, they're a match. So this would be 2 feet. And then this is 5 feet here. And then I'm going to draw the front and back. So the measures for the front and back would be, so I'm going to represent this as the front. The measure for this would be 4 feet and 5 feet. And then exactly the same shape as this for the back. So that would be, I'm going to label this as the back. And then that's again 4 feet and 5 feet. Now, this time around, we are going to determine the area for each one of these. So the area for this would be, multiply these two. 4 times 2 is, I'm just going to show the work, 4 times 2. So that would be area, by the way, there's a feet there and there's a feet there. So that would be 8 feet squared. So that's the area for the top. I'll do the same thing for here. Area is 4 feet times 2 feet. That would be 8 feet squared. And then for the left, exactly the same for both of these. So that would be area is equal to 2 feet times 5 feet. And this would come out to be 10 feet squared. And then this one right here is the same thing. Area is 2 feet times 5 feet. So that is a 10 feet squared. So that's for the right. And then for the front here, so this would be area is equal to 4 feet times 5 feet would be 20 feet squared. So that's the area for the front. For the back, it's going to be the same. So area is 4 feet times 5 feet. So the total area is 20 feet squared. So to find the surface area for this, so surface area is equal to adding these all up together. So that would be 8 feet squared plus 8 feet squared plus 10 feet squared plus 10 feet squared plus 20 feet squared plus 20 feet squared. Adding them, if we add all of these together, this would come out to be the surface area for this. Well, if we add all those together, is 76 feet squared. So this is our surface area. So that's the first method that we did. We find the surface area for each of the faces and we add them all up together. Now let's have the second method. So the second method was using the formula that we got from the from the first slide. So we're gonna plug these numbers in here. So this would be 2 times our length is, so we're just gonna look at this one right here. So the length is 4. So I'm gonna write 4 feet times our width is 2 feet. So that would be 4 feet times 2 feet. So that's the first part. Plus, we're gonna multiply the width and the height. So that would be 2 feet times 5 feet, because that's the height right there. Plus, the third one here is the length. That's the length. So that's 4 feet times the height is 5 feet. So I'm going to write 5 feet over there. So we are going to simplify this. This would come out 2 times. This would be 4 times 2 is 8 feet squared. And then that's going to be plus 10 feet squared. Plus, we have another 4 times 5 would be 20 feet squared. So then we can simplify this as 2 times 10 plus 20 is 30 plus 8 is 38 feet squared. So then multiply that by 2. So then our surface area is a match with this one right here. If you multiply 38 times 2, that would be 76 feet squared. So pretty much they are exactly the same, but then again I'm showing you 2 methods to do this. So if you forget this formula right here, the go-to method is taking the surface area, taking the area for each of the 6 sides and add them up together. The answer would still be the same. Okay, so let's move on to the next example right here. So we have a word problem here. So let's go over the problem here. So the surface area of a rectangle. So in this problem, we are given the surface area. S is 236 inches squared. And then the length is 8 inches. So I'm going to write L is 8 inches. And then we also have the width is 5 inches. So we are asked for the height. So in this problem here, there's no height. To do that, we are going to use again in this case where problems are like doing it backwards, all the other parts are missing. It can be helpful to use the formula that we have here. So we plug values into this formula that we got from the first slide. So first, the surface area is 236 inches squared is equal to 2 times we have the length is 8 inches times the width is 5 inches. So that's 5 inches, multiply them, and then plus the width again is 5 inches. So that's 5 inches right here, times the height is missing. So we keep it as h, and then plus we have the length is 8 inches times the height is missing, so we keep it as h. So then from here, we are going to simplify this. So this would be 236 inches squared is equal to 2. And then the values that we have here would be, this is 40. That's 40 inches squared plus 5 inch h. And then because they're like this is a variable, so we have a 8 inch. So let's just put a dot there. So 8 inch h. So that because the height is missing. Now from here, we want to clear this side, the left side, the right side here by dividing this whole thing by 2. Then we divide this by 2 so that we can get rid of the 2 over there. So 236 inches squared divided by 2 is 118 inches squared is equal to 40 inches squared plus 5. We can combine this 5 inch h plus 8 inch h. So we can just go ahead and have that as 13. So again, what I did here was I combined 5 plus 8 is 13. The unit here is inch h. So then from here, we want the h by itself. So then we subtract 40 inches squared from both sides. So minus 40 inches squared. So then we can cross the 40 inch squared. So 118 minus 40 inches squared would be 78 inches squared is equal to 13 inch times the height. So we want the height by itself. So we're dividing both sides by 13 inches. Divide this by 13 inches. Now remember that in this problem right here, inch squared means that's inch and inch together. So we're gonna take one of the inches here, and we take the inch here, and then these two gets crossed out. We are left with h. So h therefore is equal to 78 divided by 13 would be 6, and the unit here is inch. And so this is the height of this rectangular prism. That's it. If you find this video helpful, hit like and subscribe for more math videos. See ya!